Welcome to NGCon Online Academy. In this lecture, we will be discussing the MCQs of Sunday Test-3. Not a characteristic of amorphous solids. Irregular cleavage, anisotropy, no fixed melting point, and short-range atomic arrangement. So all of them are characteristics except anisotropy. It is not a characteristic of amorphous solid, but it is a characteristic of crystalline solids. The equilibrium constant for a reaction is 10 raised to the power minus 5. What does it indicate? Now Kc has quite a small value, which means that at the stage of equilibrium, the concentration of products is low and that of reactants is high. So in such a reaction, forward reaction is not favored, but reverse reaction is favored since reactants are more in amount at equilibrium. So B is correct option. Concentration of reactants before the start of a reaction was 10. After completion of reaction in 5 minutes, the concentration was 6. The rate of reaction is. Now this is the concentration of reactants and this is the concentration of products. So let's see the rate. So rate is concentration final of products minus initial concentration of products divided by time. Now final concentration of products is 6 and initial concentration of products is always 0. The time taken is 5 minutes. 5 minutes means 5 multiplied by 60 seconds. So it becomes 6 divided by 300. So the rate becomes 0.02. So C is the correct option. Most exothermic phase transition. So when solid gets converted into liquid, it is endothermic because it requires heat. So fusion is endothermic, liquid into gas, vaporization is also endothermic, and solid into gas sublimation is highly endothermic. Now liquid into solid freezing is exothermic, gas into liquid condensation is also exothermic, but gas into solid deposition is highest among all in exothermicity. So this is the most exothermic process. For the reaction A forms B plus C, if concentration of A is doubled, the equilibrium constant will. So keep in mind that equilibrium constant does not change with either change in concentration, pressure, volume or catalyst. The value of K is only changed by change in temperature. So it will remain the same with change in concentration. The rate of reaction doubles for every 10 degree rise in temperature. If the temperature is increased from 20 to 60, the rate increases by a factor of. So we have a formula 2 raised to the power delta n, where n is the number of times temperature is increased by 10 degree. So as we move from 20 to 30, we increase temperature by 10 degree one time. Then from 30 to 40, another one time. Then from 40 to 50, another one time. And from 50 to 60 another one time. So 4 times we have increased the temperature by 10 degree. So the rate is 2 raised to the power 4. That makes 16. So the rate increases 16 times. Which of the given is not a crystalline solid? Coal tar, table sugar, table salt and graphite. Table sugar is sucrose. It is crystalline, molecular crystal. Table salt is NaCl. It is ionic crystal. Graphite is a covalent crystal. Coal tar is an amorphous solid. Which of the following will not disturb the equilibrium position? Adding a catalyst, changing pressure, changing concentration, changing temperature. Now catalyst does not disturb either equilibrium position or equilibrium constant. Catalyst से इन दोनों चीज़ों पे कोई फर्क नहीं पड़ेगा. Changing pressure changes equilibrium position. Changing concentration also changes equilibrium position. And changing temperature changes both equilibrium position and equilibrium constant. So adding a catalyst does not change any of these. In a pseudo first order reaction, so pseudo first order reaction is that reaction in which two reactants are involved in the rate determining step. But one of the reactants is in a very limited amount, so it actually controls the rate. So the reaction is proportional to its first power. But the second reactant is in excess, so it stops controlling the rate. So the rate of that reaction does not depend on excess reagent. So one reactant is in large excess. Which of the following is not similar for isomorphs? So isomorphs generally have same radius ratio and same atomic ratio. Along with that, physical geometry is also same for isomorphs, but physical properties are different for isomers because they are chemically different, so physically they also show some different properties. The expression of Kc for the reaction is, so Kc is equal to concentration of products which are SO3 raised to the power 2 moles divided by concentration of reactants SO2 raised to the power 2 moles and O2. So this is the Kc of this reaction. So B is the correct option. For the reaction 2A into B, the rate is proportional to K into A raised to the power 2. If concentration of A is tripled, rate increases by. So this is a second order reaction in which rate is depending upon second power of the reactant A. So if concentration of A is increased 3 times, so the rate changes in accordance with second power of 3, that is equal to 9. So the rate is increased by 9 times. A unit cell is defined by how many parameters? Each unit cell can be defined and differentiated by 6 parameters, among which there are 3 parameters of length A, B and C. And there are 3 parameters of angles which are alpha, beta and gamma. So C is the correct option. Kc for reversible reaction 2HgS plus O2 gas into 2HgO solid is written as. So this is a heterogeneous equilibrium. In heterogeneous equilibrium, we do not write solid states, we only write gaseous states. So when we write Kc, so in the products we will not write HgO, so we write one as products. And in reactants we will not write Hg, but we will only write O2, so this is the Kc of this reaction. The energy difference between activated complex and reactants is, so let's assume this is reactants energy and this is the energy of activated complex. So the energy difference between them is called activation energy because reactants acquire activation energy in order to form the activated complex. If all the lengths of unit cell are unequal but all the angles are same, so the parameters are given, all the lengths are unequal but all the angles are same and they would be equal to 90 degree. So these are the characteristic of orthorhombic or rhombic system. So this is from the book's table. Units of Kc for reversible reaction 2N2O5 forms 2N2O4 plus O2. So units are equal to units of concentration mole per decimeter cube raised to the power delta N, where N stands for number of products minus number of reactants. Now here we have total 3 moles of products and 2 moles of reactants. So delta N is equal to 1. So the final units become mole per decimeter cube. So C is the correct option. Rate constant of a second order reaction is 2 mole per decimeter cube. The reaction was given as 3A into 3C. If concentration of reactant A is 3 mole, the rate of reaction would be. So now the reaction is given by this equation, but the reaction is second order. So we will write R is equal to K into A raised to the power 2 because this might be a complex reaction whose rate determining step would be second order. Now if the concentration of A is 3, so concentration of A is given as 3, then the rate constant is given as 2. We have to find the rate. So 3 square is 9 and 9 multiplied by 2 is 18. So the rate would be equal to 18 mole per decimeter cube per second. K2Cr2O7 is an example of, so this is taken from book's table, where it is an example of triclinic system. So triclinic system is the most unsymmetrical system including K2Cr2O7 and CuSO4.5H2O. Choose the correct relation for the given reversible reaction. Now, the relation between Kc and Kp is such that if products are larger than reactants, then Kp is larger than Kc. If reactants are larger than products, then Kc is greater than Kp. And if reactants are equal to products, then Kc is equal to Kp. Now here, products are greater than reactants because 2 moles of products are present and 1 mole of reactant. So products are greater than reactants, so Kp is greater than Kc. Doubling the concentration of reactant A doubles the rate, and increasing the concentration of B by 4 times increases the rate by 16 times. So rate is proportional to doubling the concentration of A doubles the rate. So A की फर्स्ट पावर पे रेट डिपेंड करेगा, जो काम A के साथ होगा वही काम रेट के साथ होगा. एंड इंक्रीजिंग कॉन्सेंट्रेशन ऑफ रिएक्टेंट B by 4 times increases the rate by 16 times. सो B को अगर हम 4 टाइम्स करें तो हमारे पास रेट उसके स्क्वायर के साथ यानी 16 के साथ वेरी करता है, तो B की सेकेंड पावर के प्रोपोर्शनल है. सो दिस इज़ अ थर्ड ऑर्डर रिएक्शन वेयर रेट इज़ प्रोपोर्शनल टू फर्स्ट पावर ऑफ A एंड सेकेंड पावर ऑफ B. Lattice energy is defined by which equation? So lattice energy is when a positive gaseous ions join with negative gaseous ions to give 1 mole of solid ionic crystal. So here this A is correct, where both the positive and negative ions are gaseous and ionic crystal is solid. 0.4 moles of acid and 0.2 moles of alcohol are reacted to give 0.1 moles of each ester and water. Kc for the reaction is. So let's take acid and alcohol and they give us ester and water. Now 0.4 moles of acid are taken and 0.2 moles of alcohol are taken. And at equilibrium we have 0.1 moles of ester and 0.1 moles of water. So let's take their equilibrium concentration as X. Equilibrium concentration of acid would be 0.4 minus X and that of alcohol would be 0.2 minus X. So 0.4 minus X is 0.3 and 0.2 minus X would be 0.1. Now we put equilibrium concentrations. So the products are 0.1, the other product is also 0.1 and the concentration of reactants is 0.3 into 0.1. So these two cancel out, we are left with 0.1 divided by 0.3. So this becomes equal to 0.333. So A is the correct option. The units of rate constant depend upon. Now we have different units of K for different orders of reaction. So the rate constant, the units of rate constant depend upon order of reaction. Different orders have different units of rate constant. Lattice energy is greatest for. So here we have been given group 1 element and 3 group 2 elements. So for group 1 we cancel it out because their lattice energy is quite lower than group 2. Now in group 2 we have MgO and CaO. Here calcium has larger size, so cancel it out. Now we have MgO and MgCl2. Now there are 2 chlorides which are larger in size and there is one oxygen which is smaller in size. Since lattice energy is directly proportional to charge and inversely proportional to size, so the smaller the size, the greater is the lattice energy. If Kc is greater than Qc, reaction moves in which direction to achieve equilibrium? So if Kc is greater than Qc, it means that at equilibrium, concentration of products would be higher than the concentration that is measured now. So whenever Qc is lesser than Kc, it means that concentration of products is lower than that should be at equilibrium. So reaction will move forward in order to increase the concentration of products and make Qc is equal to Kc. So reaction will move forward to achieve equilibrium. Order and molecularity for the given reaction. So ester plus water forms acid and alcohol. So here 1 mole of ester and 1 mole of water are involved. So molecularity would be 2. Now here ester is usually in limiting amount and water is usually in excess amount. So water does not affect the rate of reaction. Only the ester affects rate of reaction. So order of reaction is pseudo first order. So C is the correct option. Solids having lattice held by van der Waals forces are. So in molecular solids, the different molecules are held together by van der Waals forces. So C is the correct option. At a certain stage of reaction, concentration of products is 0.4 and reactants is 0.1. If the reaction moves in reverse to achieve equilibrium, which statement is true? So we find reaction quotient which is equal to concentration of products divided by concentration of reactants. So it is equal to 4. Now they are telling that if a reaction is moving reverse to achieve equilibrium, so reaction moves reverse when your QC is greater than the Kc. So it means that QC is now 4, it is greater than Kc. Which statement is true? It means that if QC is greater than Kc and reaction is moving in reverse, so the value of Kc would be smaller than 4. So B is the correct option. If the rate increases or decreases by same ratio as the rise or fall in concentration of reactant, the order of reaction is. So order is always 1 if the rate changes along the reactant. जो काम reactant के साथ हो वही काम rate के साथ हो, तो it means कि rate is proportional to first power of reactant. So the order would be 1. For an endothermic reaction achieving equilibrium, increase in temperature. So we have an endothermic reaction which is achieving equilibrium. Increase in temperature. So endothermic reaction is driven forward by increase in temperature. If we have a reaction that is endothermic in forward, so it is driven forward by increase in temperature. So in such the cases, if the reaction is driven forward by increase in temperature, products increases and Kc increases. So B is the correct option. A single step reaction is given as 2A plus B forms 2C. If concentration of A is 2 and B is 1.5, the rate is 18. What is the rate if concentration of A is 1.5 and that of B is 2? So now a single step reaction, which means elementary reaction, is given, whose equation would be from this. If the concentration of A is 2 and that of B is 1.5, the rate is 18. So we have to find the rate constant. So 2 square is equal to 4. 4 into 1.5 is equal to 6. So K would be equal to 18 divided by 6, 3. Now they have asked what is the new rate if 3 is the constant, concentration of A is 1.5 and that of B is 2. So now 3 into 2 we have 6. 6 into 1.5 square. So it becomes roughly equal to 2.25. So it becomes 13.5. So B is the correct option. More formation of ammonia in Haber's process is favored by. So what factors form more and more ammonia? H2 plus N2 forms 2NH3 and the process is exothermic. So increased temperature makes the reaction go faster, but it does not favor the formation of ammonia. Increased pressure, yes, increase in pressure drives the reaction to the side where number of moles is less. Withdrawal of ammonia, yes, if the product is removed, again reaction makes go forward. So these two are correct. So D is the correct option. Crystal of ice is an example of. So ice is water and it is a separate molecule. In solid form, many ice molecules come together to form hexagonal ice crystals. So it is example of a molecular solid. Solubility of salt AB is 1 into 10 raised to the power minus 2. Its Ksp is equal to. So salt AB dissolves into A plus and B minus. So for Ksp we write X for A plus and X for B minus. Now X means solubility, so we have solubility 1 into 10 raised to the power minus 2. We will take its square and we will get Ksp, which is equal to 1 into 10 raised to the power minus 4. So B is the correct option. Catalysts affect reaction rate by changing enthalpy. No, catalyst does not change enthalpy of reaction. Increasing activation energy. No. Decreasing activation energy. This is correct. Now this is reactant and it gets converted into product, and this is the activation energy. Catalyst just lowers this graph and decreases the activation energy. So C is the correct option. Ksp of calcium fluoride is 32 into 10 raised to the power minus 6. Concentration of calcium ion would be. Now Ksp for calcium fluoride would be written as calcium plus 2 and 2 fluoride ions. Now for calcium we write X, for fluoride we write 2x square, it is equal to Ksp. Now this finalizes to 4x cube and it is equal to KSP 32 into 10 raised to the power minus 6. Now we divide it by 4. So we get 8 into 10 raised to the power minus 6 is equal to x cube. Now we take cube root on all the sides. So we get 2 into 10 raised to the power minus 2 is equal to x. So A is the correct option. A reaction follows the rate law Ka square and to B. If A is doubled and B is tripled, rate increases by. So R is equal to K into A square and B. So if A is doubled, so rate increases by square of it, means 4 times. And if B is tripled, so its first power, so B makes rate increase by 3 times. So total rate increases by 12 times. KSP of 4 salts is given. Most soluble salt is. So most soluble salt is that salt whose KSP would be largest. So converting this value into 10 raised to the power minus 1, it is 2 into 10 raised to the power minus 1. So among all the given values, this one is the most appropriate and highest value. So the salt that has greatest KSP is most soluble. So D is the correct option. If the radius ratio of crystalline substance is less than 0.155, what is the coordination number? So this has been taken from the book table and the coordination number is 2. Addition of H2SO4 to saturated solution of lead sulfate. Now this is question from common ion effect. Whenever common ion effect occurs, the ion that is common increases in concentration. So addition of H2SO4 increases the concentration of sulfate. Now the reaction goes reversible, which decreases the concentration of lead. So what is the true statement? Increases the concentration of lead ions? No, lead decreases. No effect on sulfate? No, sulfate increases. Decreases concentration of lead. So in common ion effect, always the concentration of common ion increases and the other ion decreases. So C is the correct option. What is the activated state in a chemical reaction? So activated state is the temporary high energy state. Whenever reactants achieve activation energy, they go into highest energy state by achieving the activation energy, and this state is called transition state. So B is the correct option. Which of the two substances mix together to form a buffer solution with a higher pH, which means basic buffer? So basic buffer is formed by weak base and its salt with a strong acid. So these two are acids. FeOH2 is a weak base and FeSO4 is its salt with strong acid H2SO4. So this is a basic buffer. KOH is a strong base, it does not form a buffer. Acidic buffer neutralize H plus ion from outside by using its. So acid buffer has two components. First is the unionized acid and second is the ionized salt. Now the H plus from outside is neutralized by an ion of the salt. So C is the correct option. In acidic buffer, if concentration of salt is 10 times, so if salt is 10 times the acid, so how much would be the pH of buffer? So pH is equal to pKa of body salt over acid. Now acid has pKa of 4. Salt is taken 10 times that of acid, so we get log of 10, which is equal to 1. So now pH of the resulting buffer would be 5.